Okay, so yesterday there was a session on mathematical foundation for cybersecurity, and along with that, I think classical crypto was also covered, right? So, can you just tell me gist of what was taught yesterday or what was delivered yesterday by you? Anyone remember what was delivered yesterday? Asymmetric was taught. Just introduced. Okay. Okay. So, anything was taught about block ciphers, stream ciphers, or something like that? You heard a term called cryptology. You have ever heard this term? Cryptography, everyone heard. Cryptology. So, cryptology is a term where it's about development also and it's about cryptanalysis also. Development means how we are making cryptographic protocols which can be used and how we are breaking it also. Right? In cryptography, development is less important and breaking a cryptographic algorithm is more important in cryptographic world. Okay. So breaking a cryptographic algorithm is termed as cryptanalysis, right? That is an important term. So if we combine cryptography and cryptanalysis together, we find a term called cryptology. Okay. Now this cryptography has been divided into two different parts, that is symmetric key cryptography and asymmetric key cryptography. Anyone knows the difference between these two, symmetric and asymmetric? So, it was taught yesterday, or you learned from your college and came here? College. Yesterday also. Okay, fine. So, we have symmetric. Symmetric will be using same key for encryption and decryption. Okay. Don't think about sender and receiver and those things. For encryption also we'll use one key. The same key will be used for decryption. Okay. So yesterday you might have heard about Wigner cipher, right? So in Wigner cipher, whatever key you were using for encryption, the same key you might be using for decryption also, right? That is one of the classical ciphers. In public key cryptography, we will use two different keys, right? One for encryption, the second one for decryption. Okay. This part we will be taking in the next session, means after 1 hour. When I complete my symmetric part, then Arvind will talk about public key cryptography in detail. Okay. Talking about symmetry key, it is divided into again into two parts, mainly broadly. Okay. One is block cipher and another one is stream cipher. Any idea about these two? Block cipher and stream cipher? No. Okay. Tell me. Let uh, let's say I have to encrypt a video file that is of, let's say, 10 GB, some movie 4K file. Okay. And I have to encrypt it 4 GB. What should I do to encrypt it? How I can encrypt it? Okay, in modern day, how encryption happens? Any idea? Anyone got any idea? In modern era, how encryption happens? Leave about that shift cipher or Caesar cipher. We will add 3 and every bit will shift, or every character will shift by 3 or something. Using hash. Hash is entirely different from encryption. Hash is for authentication and integrity, just integrity. MAC is for authentication. Okay. In normal today's world, if we want to encrypt something, if the file is too large, then we will go for either string cipher encryption or block cipher. In block cipher, what we will do, we will divide or break our file into small chunks. Okay. Normally, block cipher like DES, AES, and those things, it will encrypt a particular number of bytes at a time. Okay. It will not encrypt 1 GB of file at a time, just a particular bytes, maybe 128 byte, maybe 256 byte. Okay. So whatever we want to encrypt, we will break into chunks of 256, 256, 256 byte, and we will encrypt 256 byte at a time. Okay. They can be added together. That is mode of encryption that we will learn later. Okay. Mode of operations. The other way is using key stream generators. Okay. So key stream means we will give algorithm one key and it will generate a stream of bits. It will keep on generating until unless ask it to stop now. Okay. It means that if I want to encrypt a 1 GB file, how many bits are there in 1 GB file? Can anyone tell? Don't multiply, just give me the numbers. This into that, something. 2 power 30. How? Quite possible. Okay, how many MBs are there in 1 GB? How many megabytes are there in 1 gigabyte? 1024, right? If you convert GB to MB, it is 1024. Now from MB to KB, if you convert again 1024, 1 MB will have 1024 kilobytes. Then 1 kilobyte to byte is again 1024. Okay. 1024 into 1024 into 1024. These many bytes will be there in 1 GB into 8. Every byte will have 8 bits. Right. So these many bits are there in 1 GB file. Okay. What we are going to do, we are just encrypting 256 bit at a time. It will take a lot of time, right? 256, then 256, then 256. If you are multiplying that, it is a very large number. Correct. So for those kind of thing, we have a cipher, a type of cipher called stream ciphers. Okay. What stream ciphers will do? It will generate a key stream of a length which we need. So if I want to generate a key stream of 1024 or 1024 into 1024 or directly 1 GB, it will generate those many key streams. Okay. Those key streams will be random numbers that we call as, you can say, a kind of key. It's not key, it's generated by key stream, and that will be XORed with the plain text. Whatever plain text I have, let's say I have 1 GB of plain text or 1 GB of this video file. I'll generate a key stream of 1 GB and thus XOR it. Everyone know XOR operation? Exclusive OR operation. Heard of this? Anyone who don't have any idea? Not heard of it. Sorry? Okay. Okay, so anyone who don't have any idea about this exclusive or XOR operations? What is 1 or 0? 1 XOR 0. 0. 1. How many ones? Raise your hand. How many think that it will be 1? 2 hands. Okay, how many thinks it will be 0? No hand. 1 hand. Okay, what do you mean by OR operation? What is 1 or 0? 1 or 0 is 1, right? True or false? We'll pick the true, right? Exclusive OR is when there is two different input, then only it will be 1. Exclusively OR option should be there. Okay. So for 0 1 or 1 0 it will be 1. For 0 0 and 1 1 it will be 0. Right. So that is exclusive OR. Exclusively OR should be there. OR means two options should be there. It should not be 1 or 1. 1 and 1 or 1 is not two options, only one option. So it will be 0. Okay. So this exclusive OR operation is required or used for encrypting our file with the key stream generator. That is our key stream, means block cipher, stream cipher. So the stream cipher will generate this key stream. Block cipher will take or divide your data into small chunks of bytes, and then it will encrypt it. Okay. So we are seeing some of the, not examples, some of the pattern on which these block ciphers are made. Mostly they are based on three different modes or three different patterns. One is SPN network. Okay. Substitution permutation network based. It's a design pattern. how block ciphers are designed. So I'll be showing you what is SPN network, how it is designed, what all the components are there, and in the third session we have a small play cipher, this toy cipher, which with which you can play. That is for 16-bit only, which you can check, modify, and play on your own. It's a Python code you can run and see how this is working. Okay. Second one, we'll see. Okay, how many of you have heard of DES? DES, Data Encryption Standards. No, only three, four. Okay. Before I start, what is your stream? In which stream you guys are there? Computer science or electronics or CS? Everyone from CS. Cyber security. Okay. Cyber security. So you might have heard about these terms. Only two from cyber? Three. Okay. So two or more. Five. Achha, you have learned cyber security in computer science as an elective course. Learning right now. Okay. Fine. So for all others, it's a very new topic, right? Cryptography. Hearing for the first time? We move on to yesterday class. Before that, have you ever heard about this cryptography? Heard. So what all you have heard? Okay, just heard or learned also? Learned also. Okay, fine. So we have very few audience who already know about cryptography, maybe six, seven. Others it's new, right? Anyway, fine. So I'll try to go with very basic so that everyone can understand. Okay. So I'll start with first substitution permutation based network SPN. Okay. Okay. So this is a basic structure of substitution permutation based network based block ciphers. Okay. In this, there will be mainly three parts. Okay. First is sub key mixing, second is S box, and third is P box or permutation. Okay. Sub key mixing means any block cipher if you take, that will be divided into rounds. It won't be encrypting a data in one round. Like I just told a term DES, data encryption standard, that is a block cipher that will encrypt your data for some rounds. Okay, 10 rounds it will encrypt, or 16 round it will encrypt, or 32, that will see later. Okay, so it will encrypt your data in continuation. First round encryption done, then second round encryption done, then third round encryption done. For every round, it will require a key. Key is required for every round. Block ciphers are part of symmetric. So one key is required for encryption and decryption both. Right now we are just talking about encryption, right? So every round will require a key, but we can't use the same key again and again in each round. That will be providing some security risk. So we need different key to be used in each round. Okay. So we have some key scheduling algorithm in which we'll give one key and it will generate me 10 key, 20 key, 30 key, whatever I want. It will keep on generating. Okay. So key scheduling algorithm is used to generate sub key from one key. There will be only one key, we'll be generating sub keys out of it using key scheduling algorithm. Okay. Once sub key generated, the first part is first sub-key mixing. Sub-key mixing is simple like XOR operation. Just XOR your plain text with sub-key. So key is added to your plain text. Okay. Then second operation is S box, substitution box. Okay. Substitution box is nothing. It's like a value will go inside this box. It's the lookup table. Okay. You have to see input. Our input will come to this box. You have to see what is the output of the box if that was the input. So let's say I have a S box table also here. So let's say if the input to S box was 0000. As per this table, can you tell me what is the output of that S box? Okay. From this S box, can you tell me how many bits are going into one S box? Okay. Others? How to determine how many bits are going into one S box? Or how many bits can be used to represent these values which is on board right now for S box? 16 bit. Okay. How many values one bit can represent? Can you tell? One bit, how many values can represent? 8 values. One bit can either be 0 or 1. No other possible. If we talk about bit, it's in binary, right? So binary value can be either 0 or 1. So one bit can represent two values. How many 2 bits can represent four values, right? 0, 0, 0, 1, 1, 0, 1, 1. Right? So it's like n bit can represent 2 to the power n values, right? 1 bit can represent 2 to power 1 value, 2 bit can represent 2 to power 2 value, 3 bit will represent 2 to power 3, that is 8 values. How many values are there for S box? Okay, how many of you heard of this hexadecimal way of representation of number? Hexadecimal representation of number. Okay, only few have not learned or heard about this, right? How many of you never heard of this hexadecimal representation of number? Never heard in life till now? You can raise your hand, then only I'll explain. If you're not raising, it means that you know it. Okay, anyway, I'll tell you just crisp of it. In hexadecimal, the number okay. In decimal, the number system which we use normally have 10 numbers from 0 till 9. We can make any number we want using this 0 to 9 symbols, right? In hexadecimal, we have 16 symbols, 0 to 9, then A to F. A represent 10, B represent 11, C 12, D 13, E 14, and F 15. That is a way of representation of a number. Okay. So whatever I have represented here in S box, that is hexadecimal representation. Now, if I want to represent these values in bits, how many bits are required? Maximum. If 3 bits are there, we can represent 2 to power 3, that is 8 numbers. Right? So, for representation till 15, 0 to 15, that is 16. So, 2 to power n equal to 16. Value of n is log 16, right? 4. So, 4 bits are required to represent this S box. It means that 4 bit is going inside, 4 values are going inside, and 4 values are coming out of this S box. Okay. Now, if I am writing that 0 is going inside this S box, it means that 4 values are going inside and hexadecimal representation is 0. So, binary representation is 0, 0, 0, 0. Right? And I am telling what is coming out if 0 is going out, going in the S box. E is coming out, right? E is the output. So, can anyone tell me what is the binary representation of E? E is a hexadecimal value. What is the binary representation of E? 1110. Correct. E is 1110. E represents 14. Okay. So 0000 went in our S box and 1110 is coming out of the S box. That's the only role of substitution here. A value got substituted as per the S box table. Okay. Then third part is permutation. In permutation, it's like just cross wiring. It's not like a value will be substituted. A bit will be location or position of the bit will be changed. Just cross wiring. Okay. So here you can see the cross wiring part is permutation. Permutation. Okay. Can you tell me any difference between this substitution and permutation? Both are just changing the bits, right? Substitution also we gave some bit we got output here also. Here what's happening? Let's say we are talking about just 16 bits of plain text. Okay. So these are 4 bit. These are 4. There might be 4. 4. Okay. This 4 bit went into this S box and it will be the value. Let's say the input here was 0011. Okay. Can you tell me output of this S box using this table if input was 0011? What is hexadecimal of 0011 or decimal of 0011? 3. If 3 is input to the S box, what is the output? 1. What is binary of 1 in 4 bits? 0001, right? So output of this S box is 0001. Right? Now what we are doing in this permutation layer, this 0 is coming here directly. This 0 is coming to this 5th position. Okay, its position is shifted from 2nd to 5th. This you can see here in this table, P box table, right? The first bit will remain at its position. First 1 is to 1 mapping. Second is the second bit will go to the 5th position. Okay, that's what's happening here. The second bit, this is the second bit here, it's going to the 5th position. First, second, third, fourth, 5th. Then third will go to 9th position. Okay, so this third is coming to 9th and the fourth is going to 15th position, 13th position. So here 1 will come. So it's just cross wiring. We are changing the position of bits, nothing more than that, permutation. Now, what's the difference between S box and permutation? Are both same? Why not? Okay. So replacing the value, how it's different from arranging the value? Okay, correct. Anyone else want to try? No idea? See, in substitution, okay, can you just see if the number of ones coming or going into S box and number of ones coming out of the S box is same or different? Different? Same? Same? Can you see the example on the board? How many ones are going inside S box? How many are coming out of the S box? So it's same or different? Different, right? So substitution means the weight won't be constant. It means the number of ones can change also. Permutation is cross wiring. Cross wiring means the one at one position will go to some other position, but it won't change. It won't convert to 0. Right? So that's the difference between substitution and permutation. Okay. Substitution, number of ones can vary. Hamming weight of the output can vary. But in permutation, Hamming weight of input and output will remain same. Hamming weight means number of ones. Okay, fine. So these are the three most important thing in kind of in SPN substitution permutation network based block ciphers. Key mixing, before key mixing, sub key generation. Okay, we generate sub keys, the smaller part of keys. That will be used for key mixing, then second substitution, then third is permutation. Fine. This part is clear. SPN based block ciphers. Name is clear. Substitution permutation network. There will be n rounds. Don't think that there will be only one round. There will be multiple rounds. Okay. Fine. Then that is fixed for algorithm. The one who has proposed the algorithm, they will fix the values. For every algorithm, that will be different but fixed. Fixed because for decryption, the same thing should be used. Else you won't be able to decrypt it. So algorithm is fixed, S box will be fixed, P box will be fixed, everything is fixed. Only the thing changes is key and plain text. Inside the algorithm, everything will be fixed. You have to change only key and plain text. Okay. Now second is Feastal network based. Okay. So most of the ciphers are based on either SPN or Feastal. Okay. In Feastal network, what happens is plain text will be divided into two different parts. Okay. Equal parts. Let's say if we talk about if my plain text is of 128 bits, I divide into 64 bits, 64 bits each. Okay. And then what happens? I am so worried. Feeling cold. Everyone feeling cold. Okay. Don't turn it on. Just raise the temperature to 24, 25. Raise the temperature. Raise the temperature to 25, 26, something like that. Okay, fine. So first we will divide our plain text into two different equal parts, half. Okay. And in each round of pistol based block cipher, only one of the part will be encrypted. The second part will go as it is. So here if we talk Li and Ri, initial left part and right part. Can you tell me in this round which part is getting encrypted? Left part or right part? Left, right, right. Just see, what do you think? Which is getting encrypted? Left or right? Okay, how many of you say left part? Okay, 6, 7 students. How many of you think it's the right part? Almost equal numbers. Very good. Okay, let's say if I want to represent Li plus 1 in terms of I. I plus 1 is next round, I is previous round, right? That thing you know. Ith and I plus 1, right? So if I want to represent Li plus 1 in terms of ith round, what can I write? Li plus 1 is equal to what? This Ri, right? Ri is directly coming. So Li plus 1 is equal to Ri, right? Now, was it encrypted? In this next round also we are able to get Ri directly as it is. Ri was some value in the first round. In second round also that is the same value. If I am getting the same value, it means that it's not encrypted, right? So in this round, Ri is not getting encrypted. We are getting Ri value as it is from here to here, not getting encrypted. Am I getting Li value here? Is it equal to Li? This one is equal to Ri, right? Can you tell me Ri plus 1 is, if it is equal to Li or not? Here Li is coming and it's getting XORed with something. Something happening here. We are getting output and this Li is getting XORed with this some value, and then we are getting Ri plus 1. So Ri plus 1 is not equal to Li. Only one condition is there, that it should not be 0. This output of this function. If it is 0, then you will get again same thing. But normally it won't be 0. So in pistol network based ciphers, this app function is having the most important. Okay. In this app function, there will be some mathematical operations will be going on. Some S box can also be there. We are giving our key to this particular function box. Okay. It will give me some output and that will be used for encrypting our data. I told you earlier that most of the time XOR will be used for encrypting your data, right? This is one of the examples. We'll generate some value, we'll XOR it with our plain text. Here plain text is Li. Okay, it will get XORed with it and then we'll get encrypted text. This thing will repeat many times. So in the second round, you can just think same operations going on. Here this value will come. Here app function is there. A key is going to this app function and same thing will happen like previous round. Okay. So in the second round, can you tell me which part is getting encrypted? Li plus 1 or Ri plus 1? Li plus 1. And Li was equal to Li plus 1 was equal to Ri. So finally, the right side of the plain text in the previous round is getting encrypted in this round. So two round combined, they are encrypting half and half of the text. So complete full encryption is happening in two rounds. So whenever you will see this kind of ciphers, there will be even number of rounds, 2, 4, 8, 16, whatever, 12, 10. So there will be even number of rounds possible. Okay. So two rounds are used for encrypting one time the plain text, complete plain text. Fine. Now there is one more type of block cipher which is ARX based cipher. Okay. ARX is addition, rotation, XOR. Okay. So in that, this is a simple block diagram of ARX. So in ARX, the new thing which is being introduced here is rotation. Okay. Okay. Have you ever seen this symbol, a square with plus in it? Symbol of XOR. Is it symbol of XOR? XOR has a square or a round circle. So what is this symbol? A square with a plus in it. Those who have learned cryptography, pick up. Addition is correct up to some extent, but how it is different from addition? Addition modulo operator. Correct. Okay. How many of you heard of this operation called modulus of operation? Modular arithmetic. Yesterday you had a class. Okay. So you must have seen addition modulo operator also, operations. What is 2 plus 8 mod 5? Can anyone tell? 2 plus 8 mod 5? 0. What? 2 5? 5? Sure. 5. I am telling mod 5. Okay. So what is 5 mod 5? And how you are telling 5? Yeah. Right. 5. Then again you can reduce it, right? 3 plus 2 is 5. 5 mod 5. What is 5 mod 5? See, whenever we take modulo operator, it means that the output should be a remainder. Remainder means from 0 to n minus 1 if you are taking mod n. If I am talking about mod 5, the output should be from 0 till 4 only. It can't be less than that, it can't be more than that. If we talk about mod operator. So if I am talking mod 5, it means the value should be from 0 to 4. Okay. If you divide any number by 5, the remainder will be from 0 to 4 only. If it is more than 4, then 5 will divide it again. Correct? Simple. Similarly, this is addition modulo operator. Okay. So, two values are coming into it, getting added, and then we are dividing it with some values. Some values means we are trying to keep the number of bit as same. Okay, can you tell me what is 1011 plus 1101 in binary? 1011 plus 1101. 11000, right? So you can verify your answer. Your addition is correct or wrong, right? Now, whenever we talk about cipher, the number of bits should not increase. Okay. So if let's say if 4 bit is coming from here, see I'm talking about 4 bit and 8 bit, but normally it will be higher, right? So let's say if 4 bit is coming from here, 4 bit is coming from here. Okay. After addition, it should also give me 4 bit only. It should not give me more than 4 bit. Fine. So that's why we will do a modulo operator addition. Okay. Not XOR, sorry. Addition mod 2 to the power 4. Okay. This is represented as this symbol. Mod 2 to the power 4 means it will be giving a remainder of 4 bit only. What is 2 to the power 4? 16. If you divide any value with 16, what will be the remainder? 0 to 15. Right? Maximum 15, minimum 0. How many bits are required to represent 15 or 16 numbers? 4 bit. So output will be 4 bit only. That's why mod 2 to power 4. Add two numbers, take mod 2 to power 4. That is this operation. Addition in a box. Modular addition operation. Here, what is this operation? So some of the ciphers are based on this. There will be sub-key mixing, XOR, sub-key will be mixed. Then there will be some additions. So half of the bit will be added together and remainder will be taken. And then there will be some shifts. Okay, what's the difference between shift and rotational shift? Have you ever heard of these terms? Rotation and just shift. What's the difference? Difference between shift and rotation. Okay, when we talk about registers, simple. Let's say I have a 4-bit register and I want to shift 1 bit on the right side. What will be output? You want it to reduce more. Turn it off. Everyone. Okay, can you just turn off the ACs? They are feeling cold. Yeah. Yeah, right shift. So what will be output after 1 bit right shift for this particular question? 101. Okay. Others? Others want to try? Anyone? If we just talk about shift, right shift. Okay. So every bit will be shifted right once. Okay. So this 1 will come to this position, this 0 will come here, this 1 will come here, and this will be out of the frame. Right. So final will be 101, and there will be nothing here at this particular bit register. That will be just normal shift. But if we talk about rotational shift, so in rotational, this bit will come back. Okay. So this last value will come here and it will become 1101. So that's the difference between normal shift and rotational shift. So when we talk about ARS based block cipher, it's a rotational shift. The number of bits will remain same, it won't change. Okay. Okay, fine. These are something about block ciphers. Now I'll just quickly go through one of the stream cipher or one of the component of a stream cipher called LFSR, linear feedback shift register. Anyone heard of this term? ARX full form is addition, rotation, XOR. Okay, so those three were different types of, or you can say, structures of block ciphers. Now I'm just shifting to stream ciphers. Everyone remember stream ciphers? What was stream cipher? How it was different from block cipher? How stream cipher is different from block cipher? Block cipher also XOR is used. It generates key stream. It will generate a very long key stream which can encrypt your whole data at a time. Okay. So for generating a key stream, the component which is being used is LFSR, that is linear feedback shift register. Okay. Linear feedback shift register is nothing which you saw just now in rotation, right? We saw rotation. There was 4-bit register. I told that 1 bit will go out and come back in, right? LFSR based on similar model, but there will be some operation. It's not like the last bit go and come back in. Some of the bit will go to operation, one operation will happen, and then a bit will be given as output. That bit will come as input to the LFSR. Okay. So for this example, you can see what we are going to do is, this is just 3-bit register, and let's say initial values is 001, 001, right? Now I'm telling for the next clock cycle. Okay. This is simple shift register, or you can say right shift. So values will be shifting this side. Okay. So for next clock, this 0 will shift to this position. This 0 will shift to this position. And a new value will come here. That will be XOR of 0th and second position value from the previous clock. So in the previous clock, the values was 0 and 1. What is 0 XOR 1? 1, right? So 1 will come here. Okay. Can you quickly draw this diagram and find all these values on your own? You have to find the value until unless you feel like it's repeating again. If it starts repeating, you have to stop it there. Repeating means the initial value was 001. If you see in later stage, if you are getting 001, stop it there. See, the first will shift to second position, second will shift to third, and first and third will go to XOR operator as seen in the diagram, and that will come to the first position. Okay, so initially the values were 001, right? This bit will shift to this position, this will shift to this position, and these two bits, first and last, are getting XORed. So here 1 XOR 0 is coming, that is 1. Now next clock again this 1 will shift here, this 0 will shift here, and from previous these two will be XORed and it will be stored in the first bit of this register. This pattern you have to follow. Then after how many times it's repeating? 8. So this is a small example of LFSR, linear feedback shift register. Okay, we are giving a linear feedback to our shift register. Right. This is used for generating key stream. So now you can see whatever you have generated, the 8 rounds which output which you have written. If you take the last bit of those rounds, that can be understood as the key stream. The key was 001, the initial value you kept in this LFSR. And key stream is the last 8 bit which you have generated. So this can be considered as key stream. Okay. So if you see, this will come here out after first clock, this will be out of this register. So you can consider this as output. So 1, then 0, then 0, or similarly, this is your key stream. So from 3 bit of my key, we are able to generate 8 bit or 7 bits of key stream. Sorry? SHL. Shift left. Okay. That I can't answer you. That you'll have to ask the person who has started this. Shift left. Sir, any idea? Same thing, but why don't we take shift left? Convention, right? There's nothing like that. That that's the convention. You have to fix it. Once you design a cipher, you have to make it fix that. Okay, it should be right or left. Convention is go with right. So this is just linear feedback. Okay. So there is an algorithm, Burnley-Massey algorithm, which is able to break this. Break this means given us just a key stream, that algorithm is able to find the key out of it. Okay. So in to remove this issue, linear feedback issue, a non-linearity was introduced. Okay. So non-linearity means it should not be only XOR operation. There should be some other operation along with XOR is a linear operation. Okay. So to remove linearity, they started with some other operation like AND or something else. Okay. So that we can see another example of that, that is called GP generator. Okay. So okay, this is Burnley-Massey algorithm. I don't have time, so we'll skip this. How to break LFSR. Okay. And then this is one of the stream cipher or type of uh, structure of a stream cipher which will generate a key stream, but it's non-linear because non-linear component like AND is there, which brings non-linearity to it. So that Barley chemistry algorithm won't be able to break this cycle. Okay. So these are different structures of block ciphers and stream ciphers. Okay. So I'll stop here. Now Arvind will continue with the asymmetric part of this. Okay. Before that, I have a question I want you to answer. We talk about symmetric key cryptography. Okay. In symmetric key cryptography, you say that we use the same key for encryption and decryption. How do we share that key? How the sender and receiver have same key? Let's say I want to encrypt one mail and send it to a friend in US. How my friend will know what is my symmetric key used? How he will decrypt it? Should I call and tell him that this is my key? Yeah. How to share? That's the question. Even if you are encrypting that again, you will have to share another key for decrypting that. Previously communicated physically. So I should go to US and tell, okay, I'll send you a mail. This is my key. This use this key to decrypt it. Right? Still, attacker can get that also, right? If you are sending it unencrypted, attacker can get it. If attacker can't get the unencrypted value, why to encrypt my mail also? I'll send like ASCII to my friend. I'm encrypting my mail. It means that attacker is there in the network and he or she can see my message. That's why I'm encrypted it. Now, how to send the key?